The universe is a gigantic place, but just about everything in it is made of very tiny particles. What may be the smallest, most fundamental particle in the universe?
Hey everyone, Jacqueline Howard here. I'm standing 330 feet underground at the Fermi National Accelerator Laboratory in Illinois. Now, it's where scientists are seeking out the smallest building blocks of all matter, which not only can enhance our understanding of, well, everything we see around us, but also even ourselves. You probably thought, well, we're made of tiny molecules, which are made of atoms, which are made of particles like protons, neutrons, and electrons. That must be the end of it, right? Wrong.
In the 1950s and 60s, scientists discovered the existence of even smaller particles, naming them fundamental particles, which include quarks, neutrinos, bosons, and others. Then, the standard model of particle physics was developed in the 1970s to explain how these fundamental particles and the four fundamental forces of nature, gravity, electromagnetism, weak force, and strong force, relate to each other. This journey into the subatomic realm continues, with scientists working here at Fermilab, the Large Hadron Collider in Switzerland, and other research labs around the world.
The way that we try to find out what the smallest things are is by smashing particles in what we call particle accelerators, particle colliders. And we smash them at higher and higher energies, trying to break them into smaller and smaller pieces. But for some of these particles, we haven't succeeded in doing that.
Yes, physicists literally send particles on a collision course like two race cars crashing into each other to find out whether they're made up of even smaller particles. After all, that is how scientists realized protons and neutrons are actually made of quarks. That's also how scientists discover new elementary particles that confirm the existence of things that were once only theory.
2 years ago, we discovered a completely new kind of particle called the Higgs boson, which is a completely different kind of thing than anything we've seen before. So I think that tells us that we were only scratching the surface of what these teeny tiny particles are really like.
But what is the tiniest particle of all? It's complicated. Whatever it is, it has to be something that can't be smashed into anything smaller than itself, no matter how powerful the collision. And physicists know it must be smaller than the size limit given to all fundamental particles, which is around 10 to the minus 19 meters. That's a 0 followed by 18 more zeros followed by 1. That's so small that some physicists say the only way to make sense of it is through what's called string theory, the idea that fundamental particles actually may be one-dimensional strings about a millionth of a billionth of a billionth of a billionth of a centimeter. If a single atom was blown up to be the size of our solar system, a string would be the size of one tree. That's so small that physicists actually call fundamental particles point-like to indicate that no technology that exists and that we can even imagine is able to make that measurement. But what happens when we do develop such technology?
We'll be able to understand eventually all kinds of new technologies and new knowledge that we'll be able to use in the real world.
So what other secrets do you think the smallest particles of matter may reveal? Let me know in the comments. Come on, talk nerdy to me.